Hello students, today you'll be learning chemical reactions and equations. It is the transformation of chemical substance into another chemical substance. For example, when milk is left at room temperature in summers, it creates an ideal condition of the growth of bacterium called lactobacillus, which is responsible for the formation of curd. Due to large number of bacterium, first milk becomes sour and then formation of curd takes place. Similarly, when iron items like tawa, pan or nails are left exposed to humid atmosphere, you can find reddish brown coating on them. The cause behind this is the process of oxidation. Oxygen present in the air in the presence of moisture or water vapor, it reacts with iron to form iron oxide, which we call it as rust. Or you can see an example of fermentation, which is a process by which grape must transform into wine. So yeast is used here to convert grape sugars into alcohol. So all these are an example of chemical reactions. So in a chemical reaction, a new substance is formed which is completely different in properties from the original substance. So in a chemical reaction, a chemical change takes place. Only a rearrangement of atoms takes place in a chemical reaction. The substances which take part in a chemical reaction are called reactants and usually written on the left hand side of an equation, and the new substance produced as a result of a chemical reaction is called the products, and usually it is written on the right hand side of the equation. We will see about this later on. So let us consider an example of burning a magnesium ribbon using a burner. And before burning the magnesium ribbon, you need to rub it with a sandpaper. So what do we observe is that the magnesium ribbon, it burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. There are four characteristics of chemical reaction. The first one is change in state. Now the combustion reaction of candle wax is characterized by a change in state from solid to liquid and gas. That is, the wax is a solid, water formed by the combustion of wax is a liquid at room temperature, whereas carbon dioxide produced by the combustion of wax is a gas. The second characteristic is change in color. So lead nitrate solution is taken in a test tube and you add potassium iodide solution to it, so it changes its color to yellow. The third characteristic is change in temperature. For this, if you take few zinc granules in a test tube or a conical flask and you add dilute hydrochloric acid to it, then zinc chloride is formed, but you can see that there is a change in temperature. The temperature rises. And the last characteristic is the evolution of gas. That is, a chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Now we will see what is chemical equation and how to write it. So it is nothing but the representation of a chemical reaction using symbols and formulae of the substances. Example, A plus B gives C plus D. So as told, A and B are the reactants, C and D are the products, and the arrow shows the direction of the chemical reaction, and if there is any condition, then that is written above the arrow. Now a chemical equation can be balanced or unbalanced. A balanced chemical equation, it has the number of atoms of each element equal on both sides. For example, zinc, which reacts with sulfuric acid, so it produces zinc sulfate and hydrogen gas is evolved. The numbers of zinc, hydrogen and sulfate are equal on both sides, so it is a balanced chemical equation. So according to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. So to obey this law, the total mass of elements present in reactants must be equal to the total mass of elements present in the product side. So that is balanced chemical equation. In an unbalanced chemical equation, if the number of atoms of each element in reactants is not equal to the number of atoms of each element present in the product side, then it is unbalanced. We will see an example. Iron is reacting with water to give you iron oxide and hydrogen gas is evolved. Now here you can see that the elements iron, hydrogen and oxygen, I have listed it separately with number of atoms on the reactant side as well as the product side. You can see that it is not equal. So the first step is that you have to start balancing the compound that contains the maximum number of atoms. So it may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. For this example, if you select ferrous oxide and the element oxygen, you can see that it has 4 oxygen atoms on the right hand side and only 1 on the left hand side. So we need to balance that first. So to balance the oxygen atoms, you have to multiply that into 4. You can see that the oxygen is balanced on both the sides. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reaction. Now for example here, the oxygen atoms are equalized now, but if you observe the hydrogen atoms, the number of hydrogen atoms becomes 8 on the left hand side, which is more than that on the right hand side. To balance it, one needs to multiply the hydrogen on the right hand side by 4. So that gets balanced there. Now the oxygen and hydrogen atoms are balanced, but if you see, the iron is not. To balance it, multiply the iron on the left hand side by 3. Now the number of atoms of each element becomes equal on both sides. So the final equation becomes a balanced equation. That is the process to balance an equation. You can make a chemical equation more informative by mentioning the physical states of the reactants and the products. For example, the gaseous state is represented by the symbol G, liquid state by the symbol L, solid state by the symbol S, and aqueous solution is written by the symbol AQ. If we take the same example, iron, which is solid form, reacts with water, which is in the gaseous form, which gives you iron oxide, solid form, and H2 gas is evolved.